everybody. I'm really excited to be here. It's always a lot of fun to hear all the discussions going on and hear more about what people are interested in and where they think the whole field is going. Yes, I'm Rogati. I built and lead the data team at Jawbone, and if you haven't heard of us, we're a company in the wearable space. And my team, what we're doing is making it smarter, right? Making it a little bit smarter, making it a little bit more useful. And so we're at the intersection of data science, wearables, and the Internet of Things. So that's a lot of buzzwords in one sentence, right? But so that's why I'm here today, to just kind of dig into that a little bit and talk about what's real and what's not, and what's really important at the intersection of these fields. So I'm going to start with a little thought exercise, right? So what do a stem cell, Leonardo da Vinci, and a laptop have in common? They're generalists, right? So they're generalists who excel, and they're everywhere, right? You have the full stack employee, you have the generalist startup founder, and they do a really good job. The reason they do a good job, in addition to being flexible, having a diverse set of skills, is because they have the context they need in the same place. It's focused. And I mean, Renaissance men came to denote scholars who held the entire science in their head, right? Entire scientific knowledge available at the time. And so that's readily accessible and high bandwidth communication because it's all in their head. And it's the same with a computer. You know, it's on the same computer, it's all super fast, the context is all in the same place. But there's a little problem because there are fundamental limits to what you can do with a cell or one computer or one person. So then you need to grow, right? And so if you grow, you first start with a team of generalists, right? More generalists, make them work as a team, right? And you have stem cells in the same tissue, and you have computers connected through the internet, and you have Renaissance men sending letters to each other and writing books for each other, just kind of developing science together. And this growth is only possible when they all share the context. They have the same shared context, they're on the same page. You have generalist startup founders, co-founders talking to each other. Everybody knows everything. And for a while, that works. For a long time, in the case of computers connected to the internet, right? It worked. And then you hit another limit. Right, you hit the next limit of growth. There's only so much you can do with a team of generalists. So then you have the next stage, right? The next stage of growth, which is specializing. You need to specialize. You need to unbundle, right? And you have stem cells making eyes and nails and livers, and you have the Leonardos of the world, and they're now artists and architects and engineers and painters and physicists and doctors and astronauts. And it takes a lot more of them to advance the boundary of science. The number of, I actually looked this up, the number of authors for academic papers is going up. For the Higgs boson paper, it's 6,000 authors, right? I mean, holding the entire context of science in your head is now impossible. And finally, you have the laptop, right? You have, and without preserving that context and high bandwidth communication, you have the growth that's kind of stalling. And in data and computing, we're hitting this inflection point where things are evolving from these generalist devices to specialized devices. And that's what we now call the Internet of Things, right? Connected devices that are working together. And that's the great unbundling, right? The Internet of Things. And there's an explosion of them. Cisco estimates that we're gonna have 50 billion of them by the year 2020. Gartner says 25, so taking bets. And McKinsey estimates the economic impact is going to be, somewhere around 5 to 6 trillion. And Home Depot now sells 600 smart home products, which is 6 times as many as it did 2 years ago. That's according to the New York Times. And so the Jawbone Up Band, which is our product, doesn't just track your steps and sleep, but it also turns on your lights and your coffee maker and your Nest thermostat when you wake up. And there's a lot more, right? You've seen examples all day. You saw the automatic example with cars. We have connected desks and garden sensors, and the insulin pumps and pacemakers, and wearables for your dog, and light bulbs, connected light bulbs, and your exercise equipment, and smart clothing, and my doorbell is connected, and the smart door locks and security cameras. Of course, baby monitors and onesies that are smart, smart diapers, jewelry, alarm clocks, mattresses, thermostats, water heaters, and on and on and on and on, right? So Mark Andreessen famously said that software is eating the world, right? So that's true, but it turns out that it's actually kind of the other way around. The world is eating software. Everything has a little bit of software that they've ingested, and they have it in them, so everything has a little bit of smarts, right? A little bit of software. And the key to all of this working is context, going back to context, the shared context. Because people are very good at processing context. It goes to both IQ and EQ, if you think about it. And if you're not good at processing context, it's a bit of a problem, right? It could be even pathologic, and people use words like, you're tone deaf. And that's where AI is now. It's not very context sensitive. And we all seen these advertising fails and algorithms being inappropriate or offensive because they lack the context. I mean, we heard previously the discussion around, well, the computer processing all this data doesn't know your marketing strategy. Exactly, they don't have the context. And that's partly because the bandwidth and the communication technology and the data processing capabilities was limited. And this is changing. The power of context means that you have to collect all this data and study and process it. And then this data is the lifeblood of the Internet of Things. There's been an explosion in volume, variety of signals that are coming in, and even at Jawbone, if you think about it, we have a huge influx of data. And it's not just the accelerometer readings, but you have the workouts, the pictures, the team members, the social accounts, the partner apps coming in, connecting with your house and car, and there's battery readings and hardware error codes and tickets for customer service. I like my job. And websites and data from retailers, and I didn't even touch on public data sets like weather and census data. And this data sets the context, right? All of this data together allows you to understand these global trends at scale and gives you the context. And without all of this, if you see that somebody slept for 6 hours and they woke up 3 times, you really don't know necessarily what that means, but by putting it in a context of millions of people, then that's when you can start finding out what's interesting, and you can start reporting percentiles, right? And in fact, actually, speaking of percentiles, percentiles are by definition data defining the context, right? So the first time people care about percentiles, a lot of times, or regular people, is when they have a baby, and the doctor tells them what percentile they're in, right? And so that's exactly data setting the context. And being context sensitive is what makes things feel smart and be smart. So going back to that person sleeping 6 hours, waking up 3 times a night, is that normal? Well, it depends, right? So I actually like to show this graph of age, gender, and sleep. And it basically depends on their age, on their gender. And it's interesting to see that, hey, there's a gap between men and women and how much they sleep, and then there's this a retirement bump of people getting more sleep at retirement. You have the gap that is narrowing at 51 years of age. You have the freshman 4 when people presumably going to college and gaining a little bit more sleep. And all of that is what creates the context in which you can place, from which you can learn. And another piece of the puzzle for that context is where you live, right? Different cities have their own patterns. And it's important to understand that. One interesting thing that we look into is we compared how people sleep and step and sleep and move across cities in the world. And we looked at New York and Orlando, right? So in New York, there's this very sharp regimented rhythm to the week and weekend. On the weekend, people wake up later and they get a lot more activity going, and so it's very well defined. In Orlando, it's all a weekend, right? Whether it's because people are retired or maybe because they're on vacation, right? It's the weekends and weekdays are kind of blending together. And or you can look, in Dubai, and you can see that, hey, there's this period of time when people all of a sudden start becoming nocturnal, right? And that's Ramadan. People sleep during the day and they wake up at night, and that's actually this is Dubai, right? You can find on our blog and dig into it a little bit more, understand it. And so again, context of where you live, very important. Another piece of the puzzle is weather, right? We looked into how weather affects activity. And so it turns out that people are more active when it's nice out. And so that's when you say, oh, really? You needed to look into that? I could have told you that. And that's true. But what's interesting there is that we noticed exactly how much the weather influenced people depending on the time of day. During the weekdays, when people are presumably at work, people are not that influenced by the weather. And so that gives you their context, and that's really helpful, because if I'm the Jawbone software and I'm trying to make a recommendation and tell them, hey, you should go get moving, right? And they're at work sitting in a meeting because that's what they do every day, right? That's being tone deaf. That's being not giving a good recommendation. That's not being smart and context sensitive. And so this study kind of seeing how an external variable affects how you respond really gives you insight and gives you that context. Because ultimately, right, it's not about the things, it's about the Internet of You. It's about how all of this fits together to make your life better, right? And then how all of these devices on you and your home and your environment, how are they adapting and learning, and how are they advancing your personal goals and your desires and your intents, and how people have changed to expect more of this happening. People have changed to expect things to be smart and to adapt. And so, so how do we use this data to intervene and get to that goal of improving your life? Well, you can do lots of things, right? So one example for Jawbone of how that happens is what we call Smart Coach. And this is giving you context sensitive, again, personalized advice, right? So telling you something like, oh, we notice that when you go to bed 30 minutes earlier, you take 500 more steps the next day. And so giving you an earlier bedtime to shoot for. And or you can notice that your resting heart rate was higher than average, and it's issuing this mini challenge to check off the water as you drink it, right? Glasses of water. Or another example of a context-sensitive data product in action has to do with activity classification. And the daily step graph would look like this, right? You have some steps, you have some numbers, but this isn't really how a person would describe their day. They probably say something like, oh, I worked at my desk for most of the day, and then I went for a run in the afternoon. So what you could do, given the context, is you can automatically detect these moments of intense activity, and based on your history and your activity patterns, you can guess about what you're doing and make it seamless. And over time, of course, the system can learn more and adapt to your patterns. But what's surprising about how we do this? When I ask people on the phone, I ask people questions about how we could do this activity classification. a lot of them immediately think of signal processing and how do you process that accelerometer signal. And that's part of the picture. But what's more important is the context, the time of day, how often you perform a certain activity and when, your demographic information, male, female, age, where you live even, right? Not only does it make the system smarter and more accurate, but it makes it more likely to intervene at the right time and with the right information. And that's the holy grail of modern intelligence systems. And that's just one data source, but you can start to imagine the possibilities for a truly personalized experience when you have all of these other data sources coming in. Once you consider all the way that people can bring them in. You have Whistle, again, that's a wearable for your dog. You have Munchery, automatically plugging in calorie data into your food logging, so you don't have to do it. You have Nest, you have Automatic, of course. And this is happening today, right? This is not the same overused futuristic vision of your fridge, ordering your groceries. No, this is, the connected things are here, and they're part of our everyday life. So, stepping back to that idea of growth and the idea of generalists, right? Growth brings by complexity and specialization, right? And this is true for stem cells and scientific research and companies and teams. It's even true for data scientists. At some point, I showed the description for the data scientist job that I got hired on, and it was basically, be smart, we'll teach you the rest. Which for me, with a PhD in applied machine learning and text mining, was actually very disappointed. And now, of course, if you look at the job description, they're all super specific, and they have all of these technologies that you need to know, and they're very specialized. And that's a talk for another day. So this specialization is happening as complexity comes about, but without preserving context and this high bandwidth communication, growth is stalled or leads to implosion. And in data and computing, we really hitting this inflection point today, right? Evolving from generalist devices like servers and laptops and smartphones. And yes, I get the irony of referring to a smartphone as a generalist device, but it is now. To specialized devices that make up the Internet of Things, and there's the smart connected devices that are integrated in our lives. And the reason that's possible now is because you have the technology for data streams to be collected and to intersect and be processed and to communicate in a tightly coupled way. And so in the process, that's how they're preserving context. And that's what makes it all work. So, questions? Yeah, thank you. Where are you guys going? There's a question right here.
That's a very great presentation. I really appreciate it. My observation about the Internet of Things is that it seems very misleading to me because none of the things are talking to each other. So they're all going, is a one-way communication. So I would love if I got the automatic device that my car could talk to my Nest. I would love when I plug in my Jawbone that it knows my work schedule so it doesn't send me those annoying reminders to get up and move around. But nothing is talking to each other, and we've also seen, I think Google bought Nest, and it's proprietary. So there's no way that data is going to be shared and made available. So we're just creating this whole big mess of things not talking to each other, and the value's not going to be unlocked. So
so that's actually changing, right? So all of these devices have increasingly started to have APIs that allow people to export the data and make things talk to each other. So one word, if, right? So you have if then that, you go and create recipes where you make things talk to each other. because everything has APIs and it allows you to export and import data and have communication going back and forth, and you have something that connects them together, something like IFT, and if you haven't seen it, I really encourage you to check it out. It's awesome. And that's how I can, that's exactly how I can turn on my coffee maker with my Jawbone up, because there's an IFT recipe for that, not because you need deep integration, and square everybody talking to everybody kind of thing.
I'm going to talk to you afterwards because I want my Jawbone to turn in my coffee. So.
Other questions or comments?
Can I tell you how the automatic connects to Jawbone? So since you brought it up, if you drive less than 2 miles, your Jawbone up will tell you, if you walk that, you're going to burn a bunch of calories.
Exactly. Thank you. Thank you.
And it was totally done with open APIs, and we
Yes.
both have IF channels because it was great collaboration. It was really easy to work with.
Yep.
That's a great story.
And that's the beauty of it, right? Because you don't need the companies to talk to each other. So it's not really the walled garden. You can, because a lot of them are exposing these APIs, you can actually hook them up together, and you don't even need to program. You don't need to hack them up. You can just use existing, there's several services in that vein where you hook up different APIs to each other, and you have triggers on one side and you have results on the other.
Okay, we have a question up here first.
Yeah, thanks again. I can also second that IFT is really helpful. A lot of customized recipes. But my question is does your team allocate resources, or is there a plan in the future to kind of make your other product line more data-centric, like the Jambox speakers?
Well, I mean, there's a lot of things you could focus on, right? So it's always, as always, in a resource-restricted environment, it's always a question of how can you have the most impact, right? So, so we're thinking about how we can have the most impact as data scientists every day. So that's part of that question is thinking about which product lines to focus on.
Okay, back there.
Yeah, so I have a question. So let's say if I have a Jawbone and my husband has a Jawbone, we're in the same household, we're having similar diet, we're both working out, we both have a similar lifestyle, and our data is different. Can Jawbone tell us, like, ignoring that I have candy under my pillows, like, can it tell me what's the difference, like, why his heartbeat is, like, heart rate is always perfect and mine is always high? Like, could it find a reason for that?
Right now, I don't think so. But that's an interesting question, right? And there's so many possible answers that you have to be careful before you start making these recommendations that are kind of in the medical, you start getting very much in the medical field. You have to be very careful about the impact that it has. So you have to be thoughtful about how you deploy those. So the answer is no, not right now.
Great presentation, Monica. Thank you. Question is more on the culture and the social aspects of this. As companies are getting more analytics and savvy in data, and more non-data sciencey people are learning about analytics, can you add some color to your journey in the world of data science on how you deal with or how you institutionalize what is right decision from a data, because every data has counter evidence. Every data you find, there's a counter data that proves, and where you sit in the organization decides whose voice is more powerful and things like that. So can you talk a little about that if you?
Well, so one thing you can do internally is lead by example, and so you can give talks and kind of show have some transparency around your thought process, and so you can show both sides of the coin and say, hey, we noticed this pattern, but then we also saw this, and this is how we thought about our decision about which one we should pursue, right? So being more transparent and leading by example, I think, helps there. But that's a good question for that different organizations have to solve in their own different ways. But in showing results and being careful about how you use the data and being the steward of the data is also important, right? So you have to, sometimes you have to expose all the details, but a lot of times in the communication, you have to know what details are important and which ones aren't.
Okay, up there.
You mentioned the medical space with the Jawbone question over there. Is that a space you see yourself getting into, not yourself, but Jawbone getting into, maybe have a doctor prescribe Jawbone, be able to monitor patient activity, you get into some kind of ethical and legal issues with that?
I mean, there's always we always think about how to have the most impact. So I can't comment on specific plans, right? But that's there's always a question of how you can have the most impact.
How do you see that space? How do you see the Internet of Things evolving within the healthcare space?
It's a tough one, right? The regulatory environment is still tough, and I know there's a lot of startups in the space thinking about it, and they'll figure it out, right? I mean, things will catch up. Somebody was suggesting that they're going to build this advanced medical startup for pets, and build all of this infrastructure and everything for pets, where the regulatory environment is much milder. And then when that's widespread and people see it and they say, wait a second, I want that. Why does my dog right have that and I don't? And so then that's when you're like ready to switch over to people, right? And so you just have to kind of slowly move things as society evolves.
Okay, Ari.
Yeah, so you showed us some really great examples of inferring context, inferring sort of hidden structure in the data, and then you were able to like put a name on it. And I know like that wasn't in the data. It wasn't like in the data. You're like, oh, this field says Ramadan, right? Like you had to actually like find the structure, then
Domain knowledge.
exactly. So can you talk a bit about how that process happens? Not like Ramadan is a good example, but also just like figuring out that like people don't change their activity habits during the workday. Like, how do you as a team both search for that context and then go through the process of naming it and then making decisions on it?
Yeah, so that's an interesting one, because a lot of times it's controversial, not so much controversial, but a lot of people have different train of thoughts about how to go about it. Should you start with a question and then try to answer it in the data, or explore the data and see what comes up? So that's actually, people have different opinions on that, and it's split in the data science community. And I'm a little bit on the side of exploring the data and see what it tells you, with a caveat that you have to be very careful. You can rationalize whatever you want, right? You can explain whatever pattern you see. People are super good at that, right? So you have to just kind of have those checks in place and see, hey,
So from a product perspective, like what are the hoops that you have to jump through before you name a context and then use it to change the behavior of the product?
Well,
Like-
but you
like
don't have to
wearables.
name it, right? So if you see that the weather is affecting, you have this external variable that's consistently affecting your population a certain way, and you know that and you can measure it. What you can do is test to see if your own interventions are responded to the same way, and see what happens. But you might ask, well, then where's the value in noticing the pattern in the first place? Well, that kind of gives you an idea of where to start with your, just kind of establishes some priors around where you can start your exploration with the testing, right? Instead of having this wild simulated annealing thing, you know exactly where to go, right? Because you have this variable that is outside of your control that is very well tested.
Okay, down here.
One of the articles that we had to read right at the beginning of the MIDS program talked about how when the web was really gaining commercial acceptance and it was being used in a commercial rather than an academic sense, there was this issue with like the internet was like one thing. Like if you wanted a web presence as a company, you would get a website guy, and they did like everything. They would do like website design and graphics and coding and like everything. And then as the internet matured, you get guys that focus on UX and guys that do design and guys that do coding and stuff like that. So you mentioned specialization, and that combined with something that came up earlier about how like some of the low-level stuff is going to get automated away for the most part, and it's not really going to be something that you need to pay attention to as like a specialist in the field. So with all of that in mind, how do you see the data science world falling into certain specializations? What specializations do you think are going to mature?
Yeah, I'm definitely seeing that, and I kind of alluded to that with the job description. Yes, and I agree, it's the same thing. Data scientists are initially journalists, but now I'm seeing this split that covers the pipeline, all the entire pipeline, right? So it starts with data engineering, where you have people working more on the infrastructure side and putting together the data pipelines. Then you have, so that's how it's kind of carved up in from what I've seen. You have data engineering, then you have the data scientist in the middle, and then after that you have the data visualization, or how I like to think about a data communication person that comes in and afterwards. So those are kind of the specialties that I see with the product, the data scientists working on product, kind of trying to span to be a little bit more of generalists in both doing some of the data engineering and some of the data scientists and some of the visualization. But more generally, when I look at how the job descriptions or how the hiring directions have evolved, I see those kind of three divisions of that pipeline.
Question, kind of going back to you were saying, sorry, thank you, regarding the difference between looking for patterns in the data and asking questions first. Sort of philosophically, what is the difference between looking for patterns in nature with your eyes and collecting that data, and then asking questions and looking for patterns in data? Isn't it really the same thing?
Yeah, you could make that argument. Obviously, I'm on that side, so I would make that argument.
Why is there
but
such a controversy about it?
yeah. Well, so not controversy, but like a split opinion, because you could think about, okay, you have all of these mountains of data, and so if you don't have a specific question that you're trying to solve for, you're just kind of lost and just flailing. And so you just spend years and years just kind of playing with the data and getting nowhere.
But aren't we sort of flailing in nature anyway? I mean, we're looking around at the stars. And
I guess we're trying to fix that. I don't know. But that would be the argument. As I see, Andreas has
Andreas.
I think science is about experiments. And if you really think about what distinguishes our time from the past, is that we have these connected things where with the speed of light we get answers to the questions we ask. So for me, I think it is not just looking at data, but it's actually designing experiments, which is sort of why innovation happens so fast.
right. So that's the other argument, right? That you have the scientific method. The scientific method, by definition, starts with asking a question. If you don't have that, you have nothing, right? So that's the I can argue both sides, right? But for me personally, I am on the side of exploration a little bit more, because sometimes you don't know what problem you have until you see it, and a lot of the times the problem is in the data itself. Maybe an instrumentation mistake, maybe something missing. Maybe you haven't really, there's a lot on the data quality side and just on how the data was gathered, that when you explore it, you uncover all of that before you even get to ask a question. So that's why I'm biased towards that area, but I could understand the other side of, hey, this is the scientific method, this is science, you better have a hypothesis you're trying to prove, otherwise what are you doing? So, yeah.
Okay, we have some questions back here.
So related to, all the previous questions, are you or your analysis based on observational data, or are you doing some randomized intervention to establish causality?
So generally, in a lot of these things are just kind of observation data, right? But when you're trying to think of how to give better insights to how to change their behavior so that they move more, how to help them do what they bought your product for. So in that sense, then you can do experiments where you can issue some advice that is phrased a certain way versus some advice that is phrased a certain way, and see if people opt into a challenge that you issued. So there's a lot of things you can do there where you're trying to see what's the most effective way to reach people, and so that's where you can do a little bit more experimentation. But a lot of the stuff that I'm generally showing is more observational with the biases and caveats that entails.
There's a question right there. Okay, and then yeah.
Hi. Talk a little bit about equality and data points. Do you have in your team any systems of governance or checks and balances in place? Because you have a lot of data scientists and you're putting in models together. So I was just curious as to what process do you put in place for that?
Yeah, I think what helps is having the data scientists working together off of the same rough data set or the same data sources, and so then there's kind of an open source effect in that sense, because you have many eyes looking at the same data, or looking at the same transformation of the data. So then if there are issues, then you have a higher chance of detecting them. So that's one way of dealing with that, having different people work with a common set of data. But it's interesting that you said, oh, you have data scientists building models. Building models is a tiny fraction of what we do, and so yeah.
Thank you.
Okay, you had a question?
Yeah, I asked the same question to the automatic guy. So I'm interested in so with all this Internet of Things, all these trillions of data collecting in, who owns the data? Yeah, no, I'm not skeptical. I'm just trying to put the point that all this data, there seems to be there might be a point where we'll have data have not. So you're getting all this collecting data, you're getting the advantage out of it. So is there any thought to making it open data or easily accessible for research? Anyone can get into that.
Yeah,
in that
I
kind of
think
stuff.
the closest you get there is with these APIs that everybody's developing, because what the API require is opt-in for the individual user to share their data with somebody. So if you're a researcher and you would presumably want to conduct your own experiments and so on, and you want to use data from wearables or whatever, you can use these APIs to, first you recruit your people, your subject, that you usually do, and then you can say, hey guys, can you log in with your credentials and use the API to give me access to your data, right? And so then that allows you to gather the data while having somebody fully opt into that data gathering, into that data sharing, right? So I think that movement of Facebook is the example, right? Where you sort of log in with Facebook is here's the data that this website would receive, and so that is kind of where things are going, and that's how the data is being shared across properties and being shared, from you to another person or another website.
I was one question as a data scientist. Will I get access to, let's say, Jawbone's data? I want to do some research. Is that right away? Yeah. So that's the point of it. So you have the data.
No, you
so
will not. You will get access
so what
to
is
your
the
own data, or to people you convince to hand over their credentials.
no,
So feel free to do that, right? I mean, if you set up a super compelling app that delivers value to people from the Jawbone data, and people sign up for your site and just say, yeah, I want that, your whatever you're doing is super cool, and then millions of people are just flocking to your site and sharing their Jawbone data with you, that's how you get it.
On that note, I want to say, do you have one last question? Okay, one last question because I know her.
Hi, thank you for the talk, and I'll make this really quick because I'm just dying of curiosity. You said model is a small fraction of what we do, and from what you're talking, I kind of inferred that the whole context thing had to do with making models. So I thought, that's only a tiny fraction. What do you do the rest of the time?
Well, there's that joke that says that data scientists spend 80% of their time complaining about cleaning data. That.
On
But
that
seriously, yes. Thinking about the difficulty is not the model building, but thinking about what signals you can pull in. Thinking about, hey, we should pull in weather data. And once you pulled in weather data, good luck with that, because you have things like readings that are in the same point in time, in the same point in space, at the same lat long, that are wildly different. And you look at that and you say, what is this? Turns out it's a mountain. It's different at the bottom and the top. So much of that. And right? So just thinking about what signals to pull in, that's where the value is, and that's where you can get your results. That's where your results jump. That you get a step function versus just kind of this incremental improvement that you get from improving your algorithms. Right? By pulling in new signal, you get these step functions in your performance because you just discovered a new source of information. And so that's what's more important to do and do right and make sure the data is okay than the model building itself. That is less important.
A little bit of reality check on what data scientists really do.
I'm always about the reality check.
Listen, thank you so much, Monica. It was wonderful.